Hello friends, welcome to my YouTube channel RJK Tutorials. So today I'm going to take a session on standard deviation. So standard deviation is one of the important measures of dispersion. Now standard deviation is very widely used measure of dispersion as compared to other measures of dispersion. Now if you look at the various measures of central tendency and dispersion, and as you all know that measures of central tendency includes the mean, median and mode. Whereas in case of dispersion, we have range, quartile deviation, mean deviation and standard deviation. Now compared to other measures of dispersions like range, quartile deviation and mean deviation, standard deviation has a lot of advantages. So these advantages are going to overcome the drawbacks or the limitations of range, quartile deviation and the mean deviation. Now, if you look at the various measures of dispersions, they're going to suffer from various drawbacks or demerits. For example, in case of range, it suffers from a serious setbacks because it considers only the two values. It neglects the other values in the series. That means it's going to take only the highest value and the lowest value. Remaining values are omitted. So in case of quartile deviation, it considers only the 50% of the items and ignores the other 50% of items in the series. So therefore, all the items in the series are not included. Whereas in case of mean deviation, now it ignores the negative signs. Suppose if there are any values with negative signs, it considers that to be a positive number. So thereby ignoring the negative values. So therefore, these measures of dispersion, range, quartile deviation, mean deviation is not an appropriate measures of dispersion. Now, the concept of standard deviation was first introduced by Carl Pearson in 1893. So Carl Pearson, after observing all the things, giving a more scientific way of calculating the dispersion. So while calculating standard deviation, we take the deviation of individual observations from the arithmetic mean. Then each squares, the sum of the squares is divided by total number of observation. The square root of this sum is basically known as the standard deviation. So standard deviation is basically is nothing but the deviations taken from their arithmetic mean and squaring that, and some of these squares are divided by the total number of observations, and the square root of this sum is actually known as the standard deviation. So standard deviation is the most widely and most popularly used the measure of dispersion, and it always calculated from the arithmetic mean, median or mode, but to very large extent we calculate standard deviation by the arithmetic mean. So standard deviation is the positive square root of average or square deviations taken from the arithmetic mean. So the layman definition of standard deviation will be standard deviation is the positive square root of average of square deviations taken from the arithmetic mean. So it is represented by Greek sign sigma. Now the formula for standard deviation is sigma is equal to square root of sigma of x minus x bar whole square divided by n. Now there are various formulas of standard deviation. So very widely used formulas of standard deviation are the first one, sigma is equal to square root of, sigma is equal to square root of sum of x minus x bar whole square divided by n. The other one is sigma is equal to square root of sigma x square divided by n minus of sigma x divided by n whole square. So these are the two widely used measures of standard deviations. And the first one and the alternative one, the last one. So apart from that, there are other measures, formulas are also available to measure the standard deviation, but these two methods are very widely used in case of the individual series. Now, calculation of standard deviation in case of individual observation, as I mentioned, there are two methods are there. First, by taking deviation of items from the actual mean. Another one is by taking the deviation of items from the assumed mean. So both from actual mean and the assumed mean, you can calculate the standard deviation. So when the deviations are taken from the actual mean, So in such case, the standard deviation formula is calculated by using the direct method. Sigma is equal to square root of xi minus x bar whole square divided by n, or in other words, sigma can also be calculated by square root of sigma d square divided by n, where d is equal to xi minus x bar. So xi represents the value of the variable of the observation, x bar represents the arithmetic mean, n represents the total number of observations. Now let us take an example and try to find out the standard deviation. Find the mean respiration rate per minute and standard deviation when in four cases the rate was found to be 16, 13, 17 and 22. So first of all you have to calculate the mean. So mean is calculated by x bar is equal to sigma x divided by n. So sum of the numbers divided by n, it comes to 68 divided by 4, it comes to 17. So sigma x is coming to 68. Now we have to take the deviation from the mean. So x minus x bar you have to calculate 16 minus 17, 13 minus 17, 17 minus 17, 22 minus 17. So these deviation values are minus 1, minus 4, 0 and 5. So deviation square you have to calculate. Sum of the deviation square is coming to 42. So as per the formula, sigma is equal to sum of or sigma of xi minus x bar whole square divided by n. So that comes to 3.2. So second case, when the deviations are taken from the assumed mean. So in such case, the formula is sigma is equal to square root of sigma d square divided by n minus of sigma d divided by n whole square, where d is equal to x minus a. So a is considered to be the assumed mean. So where n is equal to total number of observations. Now let us take this example where we will be calculating standard deviation based upon the assumed mean. So blood serum cholesterol levels of 10 persons are taken as 240, 260, 290, 245, 255, 288, 272, 263, 277 and 251. So calculation of standard deviation with help of the assumed mean. So in case of the assumed mean, now we have to assume some number and we have to calculate the mean. So assumed mean can be calculated as x bar is equal to a plus of sigma d divided by n. Now, so d is nothing but the deviation what we are going to take here. Now, suppose if you're taking assuming as 264, so 264 plus of 1 divided by 10. So here d is will be 1 because we are taking values as x. So some of the values will be 10 here. Now each of these values are deviated according to the assumed mean. Now let us take an assumed mean as 264. So if I take 264, I have to take the deviation from 264. So 240 minus 264, 260 minus 264, 290 minus 264. So like that, each of these D column values are taken the deviation from the assumed mean. So therefore sigma D will be 1. So T square will be 2689. Now in order to calculate standard deviation, so we have to use this particular formula. Sigma is equal to square root of sigma d square divided by n minus of sigma d divided by n whole square. Now here, assume mean you can calculate by this method, or just like that you can assume any number. So let us assume that we're going to assume number as 264. So based on that, these are the deviation values we'll be getting. Sigma d is equal to 1, sigma d square is equal to 2689. So when you substitute into this formula, the final answer will be 16.398. So this is how we calculate the standard deviation in case of assume mean method. So next one is calculation of standard deviation in case of discrete or group data. So either you can use a step deviation method, shortcut method, or assume mean method, or actual mean, or the direct method. So let us go for a problem where we have an actual mean method. So for that we have to use this formula. Sigma is equal to square root of sigma f into x minus x bar whole square divided by n. F is the frequencies here. So n is equal to sigma f. So normally in case of discrete and group data, we have to take n as sum of the frequencies. Similarly, in case of shortcut method, we have to use this particular formula. So shortcut method basically uses the assumed mean method. So that means here we going to assume some value to be mean here. So that is taken as a here. So let us take an example here. See, the data is given here. So pertaining to periods and the number of patients. Now the periods are represented as X. It starts from 10, it's going to end at 16. The frequencies are 2, 7, 11, 15, 10, 4 and 1. So therefore the sum of the frequencies will be 50. Now we have to take a deviation. So D is equal to X minus 8. So A we have to assume some number. So suppose if I take 13, then this will be the deviation what I will be getting. So this is the deviation. Then you have to calculate FD. So that is F into D column you have to calculate. Then D squared separately I have to calculate, and FD square separately I have to calculate. So in order to use this formula, I have to use this particular formula to calculate standard deviation. So these are the values I have to substitute. So sigma FD square, sigma FD. So these values I require here. So here I am getting sigma FD as 10. I'm sorry, sigma FD as minus 10, and sigma FD square as 92. So I have to substitute this and calculate the standard deviation. So remember this particular formula. So this is how we calculate the standard deviation. So we require sigma FD and sigma FD square values. Sigma FD is minus 10, sigma FD square is 92. Substitute this into this formula, we will be getting the final answer of 1.342, which is the final standard deviation value. So this is a assumed mean method, so that we are using in the discrete series. Similarly, we can go for step deviation method. So this is basically used uh, in case of group data, or where we have a continuous series. So where we have a class interval, where we have a frequency. So we divide the deviation of common class interval and use the following formula. Sigma is equal to square root of sigma fd square divided by n minus of sigma fd divided by n whole square into I. So I is nothing but the width of the class interval, where d is equal to x minus a divided by I. So this how we going to calculate the deviation. So this formulas you have to remember, this one and this one. Now when you know these particular values, it is very easy to substitute into this formula and get the final answer. So let us take an example here. So the blood pressure is given as 102, 106, 110, 110, 114, 118, 122 and 126. So sum of the frequency is coming to 100. So D is equal to x minus a divided by 4. So A I am assuming as 114. So here the width of the class interval. So what you mean by is class interval? Here we don't have a class interval, but here we have a range of values. So we are going to start with 102, we go to 126. So the difference between this number is coming to be 4. So therefore I am going to divide by 4. That is I is equal to 4. So this is how I will be getting the D values. FD values, sigma FD will be minus 12, sigma FD square will be 154. So this is actually discrete series. We are not going to the class interval problem. So in discrete series also we can use it. So final sigma value will be 4.94. So 4.94. So this formula can be used both for discrete series and a continuous series. In continuous series, we'll be having a class interval and f. In discrete series, we'll be having x column, that is x values as well as the frequencies. So in continuous series, same formula, you can see it. So we'll be having a class interval. So let us take this particular problem where we have a class interval. So the IQ levels are given in class interval as 10 to 20, 20 to 30. It goes up to 70 to 80. The frequencies are 5, 12, 15, 20, 10, 4 and 2. So some of the frequencies are coming to 68. So in case of class interval, we have to calculate the midpoint. So how to calculate the midpoint? So midpoint is calculated by adding the upper limit and lower limit dividing by 2. So that is how we calculate the midpoint. So here, so we have 10 plus 2. So the total will be 30. So that has to be divided by 2 because we are taking the average. So therefore we will be getting as 15 here. So this 15 is nothing but the average of upper and lower limit. Similarly 20, 30, 25, 30, 40, average is 35. So like that we have to calculate. So this is how we calculate the midpoint value. So once we calculate the midpoint value, D we have to calculate. D is equal to x minus a. So we are going to assume A as 45. So we are assuming A as 45, and we know size of the class interval is 10. So based upon that, we are going to get this deviation. Then we have to calculate F into D, that is frequency into D column we have to multiply to get FD. Then separately we have to take D square, then D square has to be multiplied to F. We'll be getting FD square. So these two values are important. Which are the values? Sigma FD is equal to minus 30 and sigma FD square is equal to 152. So this thing you have to put into the formula. So then we have I is equal to 10. If you multiply and divide, so you'll be getting the final answer. Now in case of combined standard deviation, so standard deviation uh, for a particular data can be calculated easy. But if you have a group of data, two group of data, three group of data, then we may have to combine the standard deviation of individual groups and make it as one group of standard deviation. Now, how do you calculate combined standard deviation? It is given by formula sigma 1 2 is equal to n1 sigma 1 square, n2 sigma 2 square, n1 d1 square, n2 d2 square divided by n1 plus n2. So in order to calculate combined standard deviation, first of all, you have to calculate combined arithmetic mean. So based on that only, we can calculate the combined standard deviation. Now here the following are some of the particulars of distribution of weight of boys and girls in class. Find the standard deviation of combined data. Which of the two distribution is more variable? Here we have data of boys and girls. Numbers are given 150. Mean weight is given as 60 and 45. Variance is given. So the difference between variance and standard deviation is variance is square root of standard deviation. If I want to convert this variance to standard deviation, I have to take the square root of 9 and square root of 4. So in order to calculate this, first of all, we have to calculate the combined arithmetic mean. So combined arithmetic mean is given by this particular formula. So we have to put this n1 sigma 1 square. We know sigma 1 square is 60. This is sigma 2 is 45. So you will be getting the combined arithmetic mean of 55. So if I get this sigma 1 2 bar, rest other things I can calculate, because in order to calculate D1 and D2, sigma 1 2 value is used. That is combined arithmetic mean values has to be subtracted from the mean values. So here I know that the mean value of boys is 60. So therefore 60 minus combined arithmetic mean value is 55. That comes to 5. Similarly for girls is 45 minus 55. It comes to uh, so it comes to minus 10. So since it's coming to minus 10, you can take the mod value. So mod is nothing but you can convert the negative to positive value by putting these parallel lines. So that comes to 10 here, because you cannot calculate a standard deviation for a negative number. So you have to keep it as a positive number. So therefore, you have to use a mod. Mod is nothing but converting negative into positive here. So we are getting D1 as 5, D2 as 10. So putting these values, I'm getting a final value of 7.57. So based on this, I have to calculate CB. So CB is coefficient of variation. Coefficient variation is nothing but standard deviation divided by mean into 100. So for the boys, I'm getting 5. For girls, I'm getting 4.44. Higher the coefficient of variation, that means more inconsistency is there. Lesser the coefficient of variation, more consistency is there. So any set of data which has higher CB means more inconsistency or more dispersion or more variation. So here we can see the variation is more for boys as compared to girls. So the answer for the question is which of the two distribution is more variable. So the distribution of boys is more variable because its value is 5 more compared to girls. So that is how we can infer it. So merits of standard deviation, very popular measure of dispersion. We can calculate skewness and correlation from it. It considers all the items in series. Squaring of standard deviation makes positive and difficult for more signs which can be expressed in case of mean deviation cannot be found here. So what is the meaning of this one is the squaring of deviation taken from a positive value is more reliable in the algebraic data, in algebraic calculations. So whenever you're taking any deviation from negative value, it might not be that much reliable. So squaring of deviation make them positive, and the difficult about algebraic signs, which was expressed in case of mean deviation, is not found here. So mean deviation may not give that much of appropriate values for measuring the deviation as compared to the standard deviation. So demerits are calculation of standard deviation is not easier as compared to range or quartile deviation. It always depends upon the arithmetic mean. So extreme items may gain a greater importance in case of individual items, because we'll be calculating d square, so based upon assumed mean. So if assumed mean is taken very too high or too small, so extreme values can get fluctuated. So that is the meaning of this actually. So here you have an example, minus 40 to 96. So here we have an extreme value of minus 40, an extreme highest positive value of 96. Minus 40 is one extreme, plus 96 is another extreme. In these cases, standard deviation values are prone to vary because of extreme values. So uses of standard deviation very widely used in biological studies. It is used in fitting a normal curve to a frequency distribution, and very widely used measure of dispersion, because based upon standard deviation values, other values you can calculate. So therefore, very extensively used in statistics. So thank you very much. I hope that you understood the concepts of standard deviation, how to calculate standard deviation in individual, discrete, and continuous series by using actual mean method, assumed mean method. So thank you very much.